Hello students, in this lesson we're going to learn different ways to write the same number. One single number can be written in a variety of ways to show different purposes. So today's essential questions are, what are some different ways to write the same number, and why is being able to write a number in different ways helpful? I would like you to brainstorm some different ways you can think of to write the number 144. So go ahead and press pause now. Take a minute, try to come up with some creative ways to write 144. Here are some good and different ways to write the number 144. You could write it as 100 plus 40 plus 4, which would make 144. You could write it as 2 times 2 times 2 times 2 times 3 times 3. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. Times 3 is 144. You could take that second set of multiplication and write it as exponents. Multiply 2 4 times, 2 to the 4th power, times 3 squared. Multiply 3 twice. You could also write it as 12 squared. 12 times 12 makes 144. Lastly, you could get very creative and use a decimal. 1.44 times 10 squared. We know that 10 squared is 100, so if you would take your calculator and do 1.44 times 100, that is 144. There are different and creative ways to write each number. So each one of these 5 ways has a special name of how it's written. Do you know what each way's name is? The first way's name is expanded notation. The second way is prime factorization. Because the third way is the same as writing the second way, the third way is another way of writing a prime factorization. The fourth way is exponential form, writing a number with a base and an exponent. And lastly, which you have not learned about yet, is scientific notation, writing a number with a decimal times the power of 10. Let's begin with another form, one that you're very familiar with, and that is standard notation. Standard notation is a way to write numbers using digits. This is how we normally write a number. For instance, if you wanted to write the number 5,210 in standard form, how would you write that? Well, you would write, using digits, a 5 in the thousandths place, a 2 in the hundredths column, and then 10. 5 in the thousandths place, 2 in the hundredths column, and then 10. 5,210. This is a number written in standard form. So let's practice. Let's pretend your income, the money that you earned last year, totaled $40,305.62. How would you write that in standard notation? Pause the video and try to write it. To write this in standard notation, you would write 40 in the thousandth column, 3 in the hundredths column, a 0 in the tens column because there are no tens, and a 5 in the ones column. Where would the 62 cents go? The 62 cents is part of a dollar, so it would need to be to the right of the decimal. Cents means out of 100, it takes 100 cents to make a dollar, so the 62 goes in the hundredths place. Expanded notation is when you write the number as a sum of the values of its digits. Each number has digits. Here is an example of a number in standard notation. It is written using 6, 1, 2, 3, 4, 5, 6 digits. We want to write them as the sum, which means to add, of the values, which means how much it's worth, for each digit. So if you look at this 2, the 2 is in the 100,000th column. So that literally means 200,000. That is the value of the 2, the value of the digit. Plus, the 3 is in the 10,000ths column, so we'll write 30,000. Plus, the 6 is in the thousandth column, so we write 6,000. Plus, the 5 is in the hundredths column, so we write 500. Plus, the 3 is in the 30. And the 6 is in the ones column, so plus 6. This form is useful when you're trying to see different parts of the number. You try this problem. Pause the video, read it, and try to write it in expanded notation. So in this problem, you are planning a benefit concert at the Giant Center in Hershey, Pennsylvania for your senior project. You are planning to sell tickets at the door. You will need to have 14,500 tickets in all. How could expanded notation describe your tickets? So we want to know, how can we write 14,500 in expanded notation, and how could that describe our tickets? This 1 means 10,000. The 4 means 4,000. And the 5 means 500. How could this describe our tickets? Well, maybe we have to order them in sets. Maybe we would need a set of 10,000, a set of 4,000, and a set of 500. It can describe ways that we could group the numbers into sets. Prime factorization. A number is a number written as the product, which we know means to multiply, of its prime. Prime means it only has 2 factors, 1 in itself. So how could we write 84 as its prime factorization? You may remember this from last year as making a factor tree. So we take the number 84 and we want to know what numbers are factors of this number. How could we divide it? Well, 84 could divide by 2 since it's even. 2 times 42 would make 84. These are both factors of 84. But only one of them is a prime factor, and that's the 2. We can continue to break this factor down into prime factors, such as 2 and 21. Again, 2 is prime, 21 is not. It's still composite. 21 is the same as 3, which is prime, times 7, which is also prime. So 84 is the same as 2 times 2 times 3 times 7. We could also write it as 2 squared, since we're multiplying 2 twice, times 3 times 7. Both are acceptable ways of writing a prime factorization. Let's work on doing the prime factorization of 250. You try it in your interactive notebook by pausing the video. 250 has a 0 on the end. That means that it could divide by 10. So we could break 250 into 25 times 10. Both of these are composite numbers. 25 is the same as 5 times 5, which are both prime, and 10 is the same as 5 times 2, which are both prime. So 250 is the same as 2 times 5 times 5 times 5, or 2 times 5 cubed. Each of these are acceptable ways of writing a prime factorization. Exponential notation, exponential form, is when you write a number with a base and an exponent. Remember, an exponent tells you how many times to multiply the base. So let's think about the number 49. what is its exponential form? What number could we multiply by itself to get 49? Well, I know that 7 times 7 is 49, so we would have to multiply 7 how many times? Twice. So 49 is the same as 7 squared. What are the exponential forms of 81 and 125? 81, I know that 81 is the same as 9 times 9. So 81 is the same as 9 squared. 125, however, I know that 11 times 11 is 121, and I know that 12 times 12 is 144. 125 is somewhere in the middle. So maybe its exponent is not a square. Do you see how the number ends with a 5? Let's try 5 and see if we can multiply it to get to 125. 5 times 5 is 25. 25 times 5 is 125. If you didn't know that, you could do it on the side of your paper. So how many times did I multiply the number 5? 3 times. 125 is the same as 5 cubed. Each exponential form does not necessarily have to be a square. It could be a cube or an exponential of higher value. An exponent of higher value. Lastly, we're going to look at scientific notation. Scientific notation is a method of writing very large or very small numbers using powers of 10. Here are 2 examples of scientific notation. You see the standard notation, and then these are the scientific notation here and here. The rules for scientific notation are you can only ever have 1 digit to the left of the decimal. So you have to have a number point, and you can have as many numbers here as you want that are not zeros. Then you always have multiplication of a power of 10 to an exponent. Now the exponent can be 2 ways, a positive number or a negative number. These do not imply a positive or a negative power. A positive exponent means that it's a big number, it's a large number, it has a high value. A negative exponent means that it has a small value. So if you look at this scientific notation with the negative exponent, you can see this is a very small number. If there was a 1 here, that would be 1 whole, like $1. If there was a 1 here, that would be like 1 cent. And we have much less than that. Here we have a positive exponent, so we have a very high number. Let's look at some examples. Here we have a very large number. You can see that it's greater than 1. To write it in scientific notation, I'm going to have a number point. I'm going to need a decimal. And I'm only going to be allowed to have 1 number to the left of it. So I'm going to have my decimal here. So I'm going to write 7.2. And remember, it will always say times 10. Now, will my exponent be positive? Because it's a big number, or negative because it's a small number? It'll be positive. Now, we will use the number that describes the difference between the old decimal, which I just drew, and the new decimal, which we placed here. And if you look, there's 1, 2, 3, 4, 5, 6 times smaller. This number is 6 times smaller than this one. We can do the same thing here. The decimal would go here, 1 place over. So we'd have 2.651 times 10. But this time it's going to be a negative exponent because this is a very small number. And then we'll count how many places difference between the old and the new decimal. 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the negative 8 power. To summarize, each notation, each form shows something different. Please pause the video and read over these forms.